Okay, so this is a video on permutations, just a little bit more in depth. I know in the last video you guys saw how to use the formula and what the formula was and what it meant to be a permutation. So this one just gives you an additional layer of information on how to do some permutation problems. Okay, so the key ingredient for a permutation is order. There has to be some sort of order to the problem. And it can be all kinds of things. It could be ordering people in line. Okay, first, second, third, fourth. That goes along with medals, giving out awards. It could be visiting something in a specific order, reading something in a specific order. Again, that's first, second, third, and fourth. That's a good example. It could be giving people a job or a role, like not first place. It could be like president, vice president, secretary, treasurer of a group. Those are options for permutations. So this is the form we use to note that it's a permutation, NPR, okay, not National Public Radio, NPR, and the N is the total number of things that we have. R is what we're choosing out of that, or the places or the awards that we're giving, the order spots that we have for the problem. Okay, now the formula for a permutation is n factorial over n minus r factorial. Okay, and I've got an example here for us to do, 8p3. So we have 8 things, and we're choosing 3 out of them. So with our formula, it would be 8 factorial over 8 minus 3 factorial, or 8 factorial over 5 factorial. Now we put that in our calculator. Okay, for those of you that don't know, in the probability section on your calculator, so if you hit the math button on your graphing calculator, you got 5 columns on there. If you go over to probability, okay, what you have there, you actually have the NPR option. It is number 2. Okay, and you can use that, that's fine. The trick to putting that in is make sure you put the N in before you go to that spot and pick NPR, the permutation button. Just like if you're putting the index on a root, you need to put that number in before on some of the calculators. Other calculators, it'll let you scroll over and type the number in. It depends on what calculator version you have. Okay, so you could use number 2. I'm going to go ahead and just use number 4. Number 4 in that section is the factorial. So number 2 is NPR, 4 is factorial. I'm going to use it so that we get to use the factorial button. So I'm going to go and choose factorial. I need 8 factorial over 5 factorial. Really, that's 8 times 7 times 6 times 5 times 4 all the way down to 1. So if you don't have your graphing calculator, or you have a calculator that doesn't have that, then you would go that route. Okay, so 8 factorial is really 40,320. That is over 5 factorial, or again 5 times 4 times 3 times 2 times 1. And 5 factorial is 120. Now you're going to divide those two numbers, 40,320 divided by 120, and we get 336. Okay, so that would be the answer to this problem, 336. Again, you could just use the NPR button, the permutation function in your calculator, and you get the same thing. Okay, so really that's up to you. Those problems shouldn't be too difficult. Okay, a couple examples here. On these, you have to set up the factorial, or sorry, not the factorial, the permutation yourself, and then use the stuff in the calculator. So there are 30 students in class, and I need to choose 2 to be line leader and door holder. How many ways can this be done? So I'm going to set it up like this. I have 30 things to choose from, 30 students to pick from, and I only need to pick 2 of them, so that's my R. Okay, so 30 is my N, 2 is my R. And I can plug that in the calculator. This time I am going to use the NPR feature. So I'm going to go to my calculator. Again, that is in the math button. And you go over to probability, and it is number 2. Okay? So math over to probability, down to number 2. My calculator, and I have one of the newer ones, sets it up like this, for 2 little boxes, so you don't have to put anything in before going there. But then you fill in your 2 boxes with your 2 numbers over here. So 30, my N, 2 is my R. The answer of the calculator tells me is 870. So there are 870 ways that I can pick line leader and door holder. Now what makes this, just as a reminder, a permutation problem is the fact that I've given them jobs. Line leader would come first because they are the leader. Door holder would come second. If you're back in elementary school, that's how it was when I was there. I don't know if it's how it was when you guys were there. That's how it's set up. Okay, so a first and a second spot. That's what gives it order. Let's look at the second one here. There are 8 racers running the final for the 100-meter dash. How many ways can first, second, and third place medals be awarded? Okay, so I have 3 spots that I'm picking out of 8 things. So 8P3. Well, that problem should look familiar because we just did it. It was on the last slide. 8P3. So I'm not even going to do any work. I already know that this is 336. Okay, if you want to practice that one, pick one of the ways in your calculator. Use the factorial, which is again under probability. It's number 4. Or use the NPR feature just to practice it. It's number 2 under probability. Okay? What too far? All right. So another way to think about these problems is we can think about them as fundamental counting principle problems. And this is really the way that I do the problems. It's fine and dandy to use the formula. It's great to use the calculator, the factorial button, or the NPR button, the permutation button in the calculator. I like to do them this way. Okay? They're just like fundamental counting problems if you break it down and think about what you're actually looking for. Okay? So let's look at this problem. Whoa, what happened? Back here. Here we go. Okay? There are 12 children doing a bunny hop race. How many ways can first through 5th place be awarded? Okay, so I could, this is really 12P5. I'm picking 5. First, second, third, fourth, fifth. I can do it that way. I could use my formula. I'm actually going to show you how this works with the formula here. So I have n, which is 12 factorial over n minus r, which would be 7 factorial. Okay? So that's really 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5. 5 times 4 times 3 times 2 times 1. Okay? Factorial 12 down to 1. 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? That's the denominator's factorial. Now what happens, anything over itself, remember, cancels out. So all of these are actually reducing down to 1. And what I'm left with is 12 times 11 times 10 times 9 times 8. Okay, that's important because if we think about this as a fundamental counting principle problem, I have first, second, third, fourth, 5th place that I'm giving awards out for. Well, how many people could get first place? Now, 1 is actually going to get it, okay, but how many options do I have for first place? Okay, I would take my little node here, and I'm going to branch that out 12 times. And I didn't do it there, but I'm just giving you a visual here. 12 times. Okay, 12 people could win first place. Now, if somebody's already won first place, how many people could win second? Well, there's 11 people left. So I would take this node, all of those, branch it out 11 times. Okay, that would be my second place. Third place, how many people, one person's going to get it, but how many people could get it? 10. Fourth place, 9. Fifth place, 8. Well, those values there, okay, the ones I did the fundamental counting principle way, are the same that I get up here when I use my formula and I cancel things out. So that's why I actually like this way, because I'm going to draw blanks for whatever number of spots that I have, whether it be president, vice president, secretary, 3. Okay, and then I'm just going to count down because my first spot, all of them could get it. So whatever my n number is goes in spot number 1. Next spot is going to be 1 less because somebody's already been picked for that first spot. Does that make sense? Okay, the one after that is going to be one less than the one before it. And I fill out my spots and then just multiply them together. I think that's easier because in my calculator I'm doing 12 times 11 times 10 times 9 times 8. And while it's more keystrokes that I'm putting in the calculator, I think it's easier to find, okay, or easier to type out. And that's just my personal preference. I do not care if you use that function or the factorial function in the calculator. As long as you're getting the answer and it makes sense, I'm fine with it. But this is a great way to think about permutations. Okay, so the answer to this problem would be 95,040. Okay, lots of ways that those kids could get their ribbons. All right, a couple things to remember here or consider. 0 factorial is 1. Okay, make sure you remember that. Items are not repeated. That's what we talked about in the last one. Since we're counting down, something or someone is always going to take that first place. So then the next spot has to be one less because things aren't going to be repeated in these problems. That idea comes up here when we talk about distinguishable. If for some reason, like maybe we're talking about a word, okay, the word apple, and we want to rearrange the letters of apple. Well, there's 2 P's in it. And I don't know which P would be different in each spot in the problem. So that's what I talk about here with distinguishable. So we wouldn't count that P twice. We'd only have to count it once. Hopefully that makes sense. And if it doesn't, I've got an example here for you. So here's our example. How many distinguishable ways can you arrange the letters in the word math? Okay, math has 4 different letters to it, which is great because every way that I order it, it's going to be different than the way before. So I'm going to use my formula for things to choose from, and I'm actually picking all 4 of them here. I'm going to put all 4 of them in order, in an order. I'm going to do this problem 3 different ways. First way, I'm going to use my formula. So I have 4 factorial over 4 minus 4 factorial, n minus r. Will be 4 factorial over 0 factorial. Okay? 4 factorial, you can put that in my calculator. Remember, it's under probability number 4 in the math key. Okay, 4 times 3 times 2 times 1. That's really 24 over, well, 0 factorial, I just gave that to you as 1. So this way, the answer is 24. All right, I could use 4p4 in my calculator. This is way number 2, where the calculator is doing all of the work for me. Okay, so I'm going to get 2 boxes like this. I'm filling them in with my numbers, and I'm also going to get 24. Now I'm going to do it the way the fundamental counting principle problem shows it. So I'm going to draw 4 blanks. Okay, I want to order these letters. Okay, and I had 4 letters, that's where I got 4 blanks from. How many options do I have in that first spot? Well, I have 4. I could have an M, an A, a T, or an H. Now, in the next spot, one of those has already been picked. So I only have 3 options for the second. Now 2 of them have been picked, so I have 2 options for the third. And last down here, everything's been picked but 1 letter, so I only have 1 option left. And when I multiply these together, 4 times 3 is 12, times 2 is 24, times 1, 24. I get the same answer. Okay? So the reason I had to do this problem, I wanted you to understand distinguishable. And I wanted to show you that these are all the same thing. So that's your quick video on permutations. Good luck on your homework and let me know if you have any questions.